Hello everybody and welcome back to another lesson. Today we are going to continue our animation for this. So our animation is going to be pieces of coal going down here and going to the ash cart. Last session we did all of this. Start top, so the waypoint builder basically it gives us the points for the little balls start to come down, like when you animate you have frames. Well, these are just the points at the frames that we put in, and also we also have the frames and as offsets, because offset plus the start frame to get when and where the balls will be. Okay, so let's use what we have here, waypoint builder, to, well, build a waypoint and start with the animate. First, let's create a def function that will run some code to actually animate the thing. It's going to be a single particle animator, but we're going to use this to animate lots of things. You might already have an idea on how we're going to use it. So we're going to call it spawn and animate one. One is a piece of coal, like a spherical piece of coal that we made, because that's just what one is. That's what we're referring to as one in this. The parameters are good. Wait. The parameter is going to be self waypoint frame. Oh. Frame offset. So what we have up here, waypoints, the points that we're going to animate using the start frame and the index, because waypoints and frame offsets are all lists and we need an index to they switch to that first waypoint, because, well, the first waypoint is where it all starts, so I need to make this a comment. Yep. Waypoint 0 is waypoints in the list to take the 0th, because the 0th is the first in lists. bfo.ops.mesh.primitive uv sphere add radius is self radius location. Well, we have the waypoint that we took out, so that we called, right, and then we can give it a name in this code. So when we want to use it, just say cool. That's what we're going to do. Scale it, and then keyframes. We can set the keyframes at the start. So bfo.context.scene .frame set. So this is where you set a frame. This is start frame. Call that location. So we'll call using this. So this sphere at this waypoint, the location, well, there's that. And then we have a keyframe which changes its location, and the frame is the start frame. Okay, but we have remaining keyframes, right? We can't just have the first keyframe for this, so remaining keyframes for waypoints. So we have a list that goes from the second waypoint, the second index in that list, the second waypoint onwards. The same thing for this. So WP and off, WP is waypoints and zip off is offsets. That's what the zip is for, so that corresponds to them. F, the start frame, plus whatever offsets of that. So it cycles through this, through every single waypoint and offset, and they're at the same waypoint 0. Waypoint 2 is at offset 2. Waypoint 3 is at offset 3. Yeah. bpy.context.scene. The frame set is F. Call.location is waypoint. Call.keyframe insert is data. Path is location. Frame is F. So we have the frame set as the start frame plus the offset. So for every waypoint, it's start frame plus the offset, which makes sense, right? And the location and the date is what we change in the frame F, so we actually use that keyframe. Okay, but our call piece has now been dropped down here and it's gone forever. We don't want it to be gone forever because then we have it go down in this animation, and that's not good. So we can reuse that same sphere and put it back up here. So let's first make code to do that. If call.animation data and call.animation data.action. So basically it's saying if the call has animation data and has animation data action, which it does because it's doing an action. For FC, fcurve and call.animation data.action fcurves. Fcurves is basically a function that helps control the movement. So for fcurves, data path that ends with location. So if the movement ends with location, so the data path, when it's changing, ends with location. It does, because keyframe insert is over here. Then we add modifiers that will make it go all the way back again, reusing the same things. So cycles dot mode before repeat yep, and so that makes it so that the code reuses the same, and we return call. Now we only have two problems left. One, we don't actually use this. We have it all defined, but we never use it. And two, this only does one. So one piece of coal goes down here, and then disappears, reappears over here, goes down here, disappears, reappears up here, and that's really slow. We want a line of coal just going down here, doing that. We can fix them all in one method. And I'm gonna add a space here. Public animate method. So let's define that. I don't indent. Animate. So the self, or the number of particles, and we can actually set them now. Make it 8 frame start, make an animation start at frame 10, and the intervals between the gaps 6. If you can change them to your liking. Or waypoints. Frame offsets is self.build waypoints, because if you remember, in waypoints it returns both of these, the waypoints and the frame offsets. Particles is 0, so the particles are in the list. For I in range, number of particles. So these are the number of particles that we have in our line. Number of particles, range, yep. For I, no, sorry, no. Start equals frame start plus I times frame gap, because they can't all start at the same place, so we can't see a difference, right? So we make them start in a line like this, so we use this to make sure. 1, 2, 3, 4. P self dot spawn, so I use the method animate 1. We're using the variables we have for waypoints frame. I'll set start I, and since we have start as the starting point, a starting frame, and these, then it's going to be in a line. So first this, and then this comes shortly after. And then finally add the animation information and stuff in the list and return particles. Okay, now we have this whole cool particle thing created. Let's put it in, run it, and see what happens. Hopefully it works. Animate coal. So CP is coal particles, and we're gonna have a lot of variables here because that's what we set it as. Great slat 00.001 is gonna be toted first, toted last. Great last 23. So those slats in the code, I remember what they're useful for, defining their waypoints and stuff. So the flat, so the toted grid and the flat grid are like that. Flat right is great slat 23. Ash name, so the copy of the ash card it goes into, we named it ash cart copy over here. Total frames per particle is 80. Steps tilt 10 steps. Flat 14. Radius of little balls is 0.05. And then we can use the animate thing. Particles is 10. Frame start is 10. Frame gap is 8. Unexpected. Oh, we don't need to indent anything. Sorry. But this should do it. Unmatched. So I guess we added an extra or didn't close it. We type that over here. Object has no attribute location. Okay, I think. Oh, that's great slat, not great loss. Okay, that solved that problem. Hold animation dot action. Okay. Is it because we didn't name Chloe yet? Because we forgot to do that. Index 02D. Oh, I forgot the equal sign. No. Okay, I solved it. It was because it was another version and this code wasn't correct in that version. But now I switched to the version I was using before, and yeah, now it works. The thing here is this is wrong, ends with. Okay. And that's actually it. We solved all the errors, so... Oh, and it's lagging. Wait a second. Alright. Let's just take a look. We can already see the cool particles over here. And if we go back in time, we can see they're moving. Let's look at them in action. Wow. You can see from our spawn a ball and animate one of them. We can it's working like this, right? I don't have to animate which repeats this for all of them. So if you could go pause and then go to the beginning, you can see that the balls are already lined up. And yeah, they're all going down. And look, I've the orange dot over here, which means I've selected this one ball and it's being reused. However, in the code you can't see it's being reused. Yep, so that's it for this lesson. See you in the next one. Bye.